Folks, we got this water is flowing into the tank over some 12-hour period, and the rate at which the water is flowing into the tank at various times is given in that table below. Okay, so we have a tabular problem. Table problem. R of T is measured in gallons per hour, and T is measured in hours. Okay, the units match up. Make sure you keep that in mind. Sometimes they'll sneak in minutes and then gallons per hour or something like that. But just keep that in mind just in case. Okay, the tank contains 150 gallons of water at T equals 0. So this is a classic setup where there's a quantity in a vessel, a quantity in a container, and then stuff is flowing in or being added to the situation at a given rate to you. Okay, it's a very classic type of problem. Where do you think people make mistakes on this one? For like part A, it says estimate the number of gallons of water in the tank at the end of 12 hours. And again, they're going to tell us what type of sum they want us to use. Okay, where do you think people make the mistake at? Yeah, they forget to add the initial quantity. So the amount of water or fluid or material that's left after 12 hours is your initial quantity plus the added amount. Okay? We did a table problem yesterday, so we'll work on this one. Let's try and do this without graphing though. Okay? So we know that we have to use a left-hand Riemann sum for this problem. 3 subintervals. Now, if we look at our subintervals, the first interval goes from 0 to 5, right? Left side height of 8, right side height of 8.8. The second subinterval goes from 5 to 8. Are these equal width subintervals? No. So we can't do like that factoring thing we did yesterday and then add up the different heights. So we actually have to write down all the different products. And then similarly, we have a width of 4 here. Okay? Let's see. So the amount in after 12 hours, and we got to make sure this goes 0 to 12. Sometimes they'll have 15 over here, and you got to cut it off at 12. So keep that in mind also. So the amount is 150. And we're going to write it all out before we do anything. Plus, so initial amount plus the added amount using left-hand Riemann sum. The width of the first subinterval is 5. So our width is 5. And then the left-hand height is 8. Plus the width of our second subinterval looks like 3 times the left-hand height of 8.8 plus the width of the third subinterval, which would be what, 4? And the left-hand height would be 9.3. Now, what is the units on our answer? Gallons. They even kind of told us, right? And again, if we had hours times gallon per hour, hours cancel, left with gallons. So this would be the number of gallons left in. Okay? And go ahead and use your calculator for this one. And again, it specifically says show the computations that lead to your answer. You have to write it out like this. You have to write those products. Those area products. 253.6, that's what I got. Okay, questions on that? Pretty easy? All right, next one. Let's do the right-hand Riemann sum for 12 hours. Again, it didn't change on us. Okay, and then we're still using 3 subintervals. That means we better have 3 products written. And again, it says estimate the number of gallons in the tank. Okay, so you better begin with the initial quantity that's in the tank and then add on what is added into the tank. Okay, we still have our width of 5, but we're using right-hand height, so it'd be 8.8. Still have the width of 3. We got 9.3. And then we have 4 and 9.2. Now we can up the ante and write a formal answer. The amount of water in the tank after 12 hours is 258.7 gallons. Okay, questions on that? Pretty easy, especially if you did your homework last night. Oh, good. It is approximately that. We could add that. Approximately. Yeah, good call. Okay, part C. Everybody's favorite. Let's do trap sum. And then, of course, 3 subintervals. So let's find the trap sum. All right, start with the initial quantity. And by the way, they could change the wording on this question by saying how much is added to the tank over that 12-hour period. Then you wouldn't start with the initial quantity, right? You just figure out how much was just added. Okay, trap sum. So we got what? 150 plus, okay, the area of the trapezoid, 1/2. Okay, the width of the subinterval would be 5. And then the sum of the two heights, 8 plus 8.8. Okay, that would be the first trapezoid. Second trapezoid, 1/2. Width of 3, if I remember correctly, and then it would be 8.8 plus 9.3. And then 1/2. Width would be 4, and then 9.3, 9.2. Anybody check to see if it is the average of the left and the right?